Hello everyone, my name is Karsha Bansal and today I am going to present my project titled Interprocess Communication Debugger. It is developed as a part of my operating system coursework. This project focuses on simulating and visualization communication between processes using different IPC methods. Now I will begin with a brief overview of the project. Let's begin with the presentation now. Interprocess communication allows multiple processes to exchange data and coordinate their operations in an operating system. It plays an important role in multitasking system where several processes run simultaneously. It helps prevent issues such as race condition and data corruption by ensuring proper synchronization between processes. There are several IPC methods that are used in operating system such as pipes, message queues, and shared memory. Pipes allows communication between related processes, message queues store messages in order, and shared memory allows fast data exchange. But these methods also introduce some challenges such as deadlock, race condition, and synchronization issues. The main objective of this project is to create a visual debugging system that simulates IPC communication, visualize message flow, detect deadlocks, monitor performance, and provide debugging interface to understand process communication behavior. The technologies that was used in making of this project are Python and FastAPI for backend development, JavaScript, HTML, CSS for front-end visualization. The system includes features such as real-time process visualization, multiple IPC methods, deadlock detection, performance metrics, system event logging, and interaction. Now I will demonstrate the working of my project. This is the main dashboard of the IPC Debugger system. Here we can see multiple processes represented as nodes in the process graph. Each circle shown here represents a process. The connections between these nodes represent communication between processes using IPC methods such as pipes, message queue, and shared memory. The color indicates the state of a process. The green represents a running process, yellow represents a waiting process, and red represents a blocked process. It is usually due to synchronization issues or deadlock. And here on the right side we can see a list of processes along with their process ID and memory usage. Each process is assigned an IPC method such as shared memory, queue, or pipe. And as we click on one process, we can see its detail such as its ID, name, state, IPC type, its resource usage, the messages that is it has sent and received, connections with other processes, and control. We can control its state by changing from blocked to waiting, from waiting to running. We can see first it was like now it's running. If we click here, it is in waiting state now. We can also kill this process by clicking here. As we deleted it, a new process came into our operating system. On the top right corner here we can see a button to create a new process. As we click here, we can create a new process by giving a name. For example, I'm creating a process by giving it a name process 1, and we can choose its IPC mechanism. For example, I'm creating a shared memory process. I will create here. Now see this, I have created a new process. I can see its name, ID, and its all the details. And here by injecting this deadlock, I can simulate deadlock condition with the help of this button. If I click here, a deadlock will be injected. This is a deadlock. These three processes are in deadlock situation now. When a deadlock occurs, processes become blocked and cannot continue execution. It demonstrates synchronization problems in multiprocess system. The red nodes represent blocked processes caused by deadlocked condition. If we click on clear, the deadlock will be removed. And if we click on burst, it generates multiple messages quickly between processes to simulate heavy communication load. Now moving on to our next section, that is metric section. It displays real-time performance data of the system. The first one is total messages. It shows how many messages have been exchanged between processes since the system started. Messages per second shows the rate at which messages are being transmitted. It is message rate. Average latency, it represents the time taken for a message to travel from one process to another. Throughput indicates how much data is transferred in a given time period. Active processes shows the number of currently active processes running in the system. And block process shows how many processes are currently blocked due to synchronization issues or deadlock. The IPC channel activity graph, it shows the usage of different IPC methods such as pipes, messages, queues, and shared memory. Now moving on to our next section, that is message flow. This section displays real-time communication between processes. The first column is timestamp. It shows the exact time when a message was transmitted, its IPC type, and the source and destination from the process that sent the message and the process that received it. The column size shows the size of the message in bytes, and the latency column shows how long the message took to its destination. On the left side, we have the navigation panel, which allows switching between dashboard, metrics, message flow, deadlock simulation, and logs. In conclusion, this system provides a real-time visualization of inter-process communication and helps detect synchronization issues such as deadlocks. It improves understanding of IPC mechanisms and helps analyze system performance effectively. Thank you.